Hello everybody and welcome to another ATC Maths and Science tutorial video. Today we'll be discussing galvanic cells and how to write down the net ionic equation. The first thing we need to do when trying to write down the net ionic equation is obviously identify between the two given electrodes which electrode is the anode and which electrode is the cathode. There are, as discussed in the previous video, three ways to determine anode and cathode. Those three ways would have been through the use of table 4b, our table of standard potentials, through observations in terms of loss or gain in mass, or knowing which electrode is positive and which is negative, whichever information supplied to us. We would use that to determine which of the two electrodes is the anode and cathode. In this particular case, the anode will be zinc and the cathode would be copper, and we would have used this table in order to identify it. It's our table of standard reduction potentials. As we can see clearly, the zinc reaction, is higher on the table than the copper reaction. Therefore, zinc will be oxidized and copper will be reduced. And so when we're writing down the oxidation half reaction for zinc, we would then write the reverse reaction. But for copper, since it is being reduced, we would write the forward reaction. Always the oxidation half reaction is the reverse half reaction, or is the reverse of what's happening here from the table, and the the reduction half reaction is always going to be the forward of what we get from the table. So just writing that down for this particular reaction, we would have our oxidation half reaction to be Zn gives me Zn2 plus 2 electrons, and the reduction half reaction would be Cu2 plus 2 electrons, that gives me Cu. Now, in order to find the net ionic equation, I need to add these two reactions together. However, there is a rule. The rule is, in order to add two reactions together, the two half reactions, I need to have the number of electrons in both half reactions to be equal. And as we can see in this example, clearly that is the case. So if we happen to add these two reactions together, we would see here on the reactant side, we would have Zn and Cu2 with the number of electrons cancelling off because they're equal. And on the product side, we would have Zn2 plus Cu. And this would be our net ionic equation. But what about an example where the number of electrons, unlike this case, are just not going to add up? It's not going to give us just be equal to each other and cancel off like it did in this example. Let's see an example like that. So let's say our oxidation half reaction, let's say that's Al, aluminium, which gives us aluminium 3 plus 3 electrons. And our reduction half reaction, let's use the same one we've used previously, Cu2 plus 2 electrons gives me Cu. Right? So in a case like that, clearly the number of electrons, they're not adding up. It's 3 in one reaction, 2 in the other. So what we're going to be finding in order to add these reactions is an LCM, lowest common multiple. And that would be by multiplying the first reaction, all the terms, by 2, and the second one by 3. So this would give me 2Al, 2Al3 plus, and this would turn out to being 6 electrons. And here we would have 3 Cu2 plus, 6 electrons, and 3 Cu. And so now, if we try to add these reactions together, number of electrons are equal, so we would have 2 aluminium plus 3 Cu2 plus, giving me 2 Al3 plus 3 Cu. And that would be how we would find the net ionic equation for a reaction where the number of electrons in the oxidation and reduction half reactions are not equal.